Okay, so for rational functions, this is something you should be relatively familiar with on a smaller scale, but now we've incorporated a numerator or denominator with a quadratic element. So the most important thing to remember about rational functions is to graph your asymptotes. So there are vertical asymptotes, and the way you find those is by setting your denominator equal to 0 and solving. So for this first one here, there could be, more than likely will be, two vertical asymptotes because there are two solutions where a quadratic function is equal to 0. This one, however, would just have one vertical asymptote where the denominator is equal to 0. As far as horizontal asymptotes, if the numerator power is less than the denominator, then the horizontal asymptote will start at 0. So that would be an equation that looks like this one. Then the horizontal asymptote will start at 0, meaning that if there's an additional vertical shift off on the side like this, then it would change. You would do 0 plus whatever that C value is, but we're not talking about that. If the powers are the same, then you take the coefficients of the numerator. So that's neither of these two examples, but if you had ax squared over bx squared, then your horizontal asymptote would be a over b. As far as when the numerator power is greater than the denominator, so that would be this one here, there's no horizontal asymptote, but you do need to check and see if there is a slant or oblique asymptote. IB uses both of these words. I probably use slant a lot more often, but all you have to do is simplify until you have a linear function. So the way you do this is by using long division and excluding the remainder. Now, you should have learned how to divide, how to do polynomial long division, but in case you forgot, I added it to the Delta Math for you to work on as well. The other important parts on a graph when you're sketching rational functions are the y-intercepts, which no different, you set x equal to 0. The x-intercepts, which is no different, you set y equal to 0. And the holes. You might remember holes from the discontinuities portion of calculus last year. This is where the numerator and the denominator cancel a factor. So if I factor this denominator and it happens to cancel out the numerator, then that means there is a hole at that equation. So first things first, as far as these problems, I'm just going to move them up for y'all's sake. For homework, we're going to make number 1, we will make Jacqueline and Liz. So what you're going to do with these problems is you're going to write out all of this information. If there's a vertical asymptote, horizontal asymptote, oblique, y-intercept, x-intercept, hole, and then you're going to sketch roughly what the graph should look like. You can split that up however you want or work on it together. So the first one will be Jacqueline and Liz. The second one will be Bella and Knock. And the third one will be Sonia and Rohan. The fourth one will be Leonard and Andrew.